All right, guys, let's get started. Sorry for the delay. I was waiting for a mic actually. My name is Luis Pavon, and we're going to be talking about convergence between GlusterFS and OpenShift. It's very, very exciting technology. I hope you're excited as I am about this. And I work also for Red Hat Storage, and I'm very excited about this. So there's a name that we gave this solution. We gave it the name Aplo. Where does it come from? It comes from Klingon. If you can see right there, he's saying it right there. He said, yes, Aplo means containers, right? But what is Aplo really trying to do? It is a solution of three technologies. The first thing we need to do is figure out how to containerize GlusterFS, and then deploy it in OpenShift. That's the first part. That's easy, it's not so bad. The second part is a little more complicated. Once we do that, we want to use OpenShift services to manage the storage. And that's the big thing here. So let's take a look first at what we plan to do for the project as a whole, and now as we go forward. The very first thing we're going to do is that we want to be able to have this technology called dynamic provisioning in Kubernetes and OpenShift, which will allow us to do the following. For example, a developer, they first would create a volume claim. A volume claim means that the developer, if you understand OpenStack, it's like requesting a Cinder volume or requesting a Manila volume, Cinder block volume. And here, a developer is making a request for a volume. Once that request goes to OpenShift will automatically go into the storage system and provision that storage for you. Once that storage is provisioned, it is then registered and bound with that claim. When it is bound with the claim, then the developer can take that claim and use it in their container. So if you understand this model, this is very familiar to you. If you use OpenStack or AWS, you first create your volume, then you attach it into your virtual machine. This is the same type of workflow. So currently, OpenShift and Kubernetes does not have dynamic provisioning, so we're doing a little bit different. First is that the administrator has to create all the volumes and pre-register them with the system, with OpenShift. Now it is the same workflow as before, where we have the developer make a request into OpenShift. That request gets then OpenShift looks around for a volume that it can match this request with and satisfy it. And then when it is bound, then the developer can then use this volume in their container, just as before. So from the developer point of view, it is exactly the same workflow. But from the administrator point of view, it's a little bit different. So this is what we plan to release first. But what is happening here? And I want you to really think about it, because this is a big, big change. The very first thing, if you think about it, is when you deal with storage systems and you deploy them, and I've been doing this for many years, is that you first have to have a storage admin set up your storage cluster in a specific way, right? So when they set it up, you have to make requests. For example, I want a LUN, or I want a volume, and I want it to attach to that system, or I want it to attach to that system. And it's very much like a cook, exactly picking the way that they want to make the meal. But in using OpenShift and Converged storage is a completely different model. In here we have what we say, it's like sitting in a restaurant and asking, I want this type of meal. And then the system sets it for you. So there's no more need to set up a separate storage system and a separate OpenShift system, having two different administrators exactly picking the volume that you want, exactly connecting into the system you want. In this system, you say, I want a Ruby on Rails with MySQL, with this volume, I want it with this DNS name, go. And it sets it all up for you. It's a big, big change coming. So let's take a look at the architecture and see how it looks like. And here, for example, if you understand OpenShift, and we'll be going into the three technologies that enable this a little bit deeper, but I just want to give you a heads up on the overall view. So the very first thing is that in an OpenShift cluster, we don't have separate storage cluster. We have one cluster, and then we have one client, the OpenShift client. Okay? And on the OpenShift cluster, we have, if you know OpenShift, you have a set of master nodes and you have a set of nodes. And master nodes are the ones that run your master system, etcd, and so on from Kubernetes. And then they can also run containers, but they don't have to. You have the choice of running containers there or not. The OpenShift nodes are meant to run your containers for you. Now here, let's take for example that you have a data center and you have a set of blades, right? And you know those blades, you have maybe 3, 4 drives, maybe 2 SSDs or so. And you have all these blades, but you don't know what to do with that storage. It's just a few, right? What would happen if you deploy Gluster into those systems? And now Gluster can take that storage that was not very well utilized before and then become part of the infrastructure and provide that storage back to your applications. And the key thing here is that if you know GlusterFS, you normally always talk about a single cluster. And you always talk about how can I take that cluster and add more storage to it by expanding the cluster. But in this model, instead, we're going to do something different. Instead of expanding storage and providing more storage by increasing the cluster size, we're going to increase the amount of storage available to the system by adding new clusters. And what does that mean? It means now there's almost no end to the amount of storage you can add, because you can just continue adding clusters to your system. Okay? So let's go into the technologies that enable this. There's 3 technologies that enable it. First, it's OpenShift, which again, if you know or don't know, it is based on Kubernetes as its main engine, and it provides us other sort of services. Second is GlusterFS for being so agile and the ability to be able to almost install anywhere, VMs, containers, whatever. And the ability to provide replicated distributed storage, very reliable storage. Lastly, something new called Heketi. It is a dynamic volume manager service for GlusterFS. What this allows you to do is being able to deploy Gluster in many clusters. Okay, and not only that, but if you use GlusterFS and you created your own bricks, this takes care of that for you. The only thing you have to ask Heketi for is, I want 100 gig volume, or I want 10 gig volume, I want an EC, or I want a replica 3. And it does that for you. It has algorithms to determine where to place the bricks. But we're going into that in a little bit. First, let's take a look at OpenShift. OpenShift itself, if you're new to it, it is based on Kubernetes. It allows for Kubernetes to have multi-tenancy. It has security services in it. It has things like templates. It has made things easier to use in a multi-tenancy environment. And again, it can run on both RHEL or RHEL Atomic or CentOS or Fedora Atomic. Now, this part here, I thought about having or not having, but I think I need to have it. And this is all the jargon and all the definitions on OpenShift. If you're new to OpenShift, like I was not too long ago, I'm really a storage guy, and I need to learn all of these terms that OpenShift has. So we're going to go through them. Bear with me. It's going to be fun at the end. So the first thing is containers. When we talk about containers, what are they? Today, they're Docker containers. And as we go forward in later releases, they could be something else like Rocket, or they could be RC containers, or something else. Second, it's a node. A node, when we define a node, it's a system that runs containers. Third is the masters, where you communicate with the APIs to be able to communicate with Kubernetes or OpenShift. Hostnet. Hostnet is a very interesting one. Normally, when you deploy a container inside OpenShift or Kubernetes, What it does is that, specifically OpenShift in this one, is that it sets up your container on a software-defined network, which is fine. But when we deploy GlusterFS, we don't want it on the SDN. We want it on the host network. That means that the container has access to the same NICs that are on the host, not over software-defined network. Okay, so at any time you open a port, they're on the ports on the NICs. Privilege mode, it enables containers to have root access. For example, in GlusterFS, we needed privilege mode because we needed access to the raw storage on your systems. So that means those disks that you had that were not used before, now those disks will be available to be used by GlusterFS in privilege mode. Lastly there is the labels. Labels is just a simple way to attach a key value to any type of OpenShift object. That could be a pod, that could be a service. We're going to go into that a little bit. Lastly is the OC. OC, if you see this, you're going to see this a lot as we go forward. OC is the OpenShift client. If you've used Kubernetes, it's just exactly the same almost as kubectl. Okay? Next here is we have pods. We're going to be talking a lot about pods here in OpenShift. What is a pod? A pod is your application. A pod is a set of containers, or normally a single container, that runs on a system. But that is the unit that most application developers concentrate on. A pod normally then, if you have two pods, like if you have a MySQL pod and a Ruby on Rails pod, or JBoss pod, and you want to be able to communicate to your MySQL pod, but you need to know where it is. You need to know the IP address. You provide a service. What you do is you request a service from OpenShift Kubernetes, and what it does, it creates a name for you that is then accessible over the software-defined network. That way your application knows exactly where your MySQL database is. All right? What happens now with your app? Can you access this outside the cluster? Not necessarily, unless you put a route. A route exposes the application outside the OpenShift cluster. Without the routing, you need to be part of the cluster, but with the route, now you have the application with a DNS entry that's then accessible outside the cluster. If you've used OpenShift online and it gives you a big long name, that's what the route is. It's the exposed name. And then endpoints is just something for the system. OpenShift and Kubernetes is the ability to find other services in the network. And then lastly here we have the persistent volume and the volume claim. Well, let's take a look at the pod first. This is an example pod. And if you've never seen OpenShift pods, here's an example. All we say here is we want to be able to run a container called BusyBox. Okay? Once you start up that container, run this command inside of it. You don't have to do it that way. The container definition from Docker file could have its own command. But in this one, we're just running BusyBox, so we're giving it a specific command. Then this is the cool stuff at the bottom here. Here we have a persistent volume claim that we have created. That persistent volume claim, we give it a name so we can reference it inside the spec section. And now we're saying we want that volume claim to be mounted in /GlusterFS. So everything's starting to come together. When you create a volume in Gluster, or create any type of storage system, you create a claim. That claim has a definition of how to access that storage. That storage would then be mounted for you by Kubernetes and OpenShift in that location. If the container crashes, and this has a replica set which we're not going into today, but Kubernetes has the ability to take this pod and then restart it on another node. For example, if something happens to that node for you, and then remount that persistent store. Let's take a look at routes. Again, routes allow external traffic to come into the system. Now, I really wanted to point this out because I am a storage guy, I'm not a DNS networking guy, and it took me a little while to really understand this. I was trying to think about, there's only one route container. It's listening for all your apps are inside, and it's doing that because there's some headers in the external traffic that they come in and define what application it's going to go into. And that's how the HA router is going to manage that for you. Lastly, let's look at its persistent volumes. And I wanted to bring this up because there's a lot of confusion around how is it that the container is going to access my GlusterFS storage. A lot of questions around, well, if it's doing it over the SDN, is it going to see it? How can we make sure that it can access it? And so on. The way it works is that GlusterFS, being on the hostnet, exposes the volumes on the system itself, on the hostnet, on the cluster network. Okay? That enables other nodes running your container to be able to access the volume. What they do, using a plugin in Kubernetes, is that they mount the volume. They're the ones who mount it. The nodes are the ones that mount it, not the container. Once the volume is mounted, if you know GlusterFS, you use Fuse for mounting. So it provides HA. Once that's mounted, then when the application started, it is bind mounted to the location that was requested in the pod name. So again, it is mounted by the node. It is node-to-node mounting just as any other GlusterFS setup. Once that is done, then it's bind mounted into the application. Okay. Lastly, just a few more definitions. Thank you for bearing with me on these. There's a lot of them. So, job. What is a job? A job is a really, really cool object. What it does is that it's like a pod, but it has a beginning and it's an end. For example, if you wanted to compress 10,000 images and you wanted to parallelize it across the entire cluster, you use a job. It goes through, it scans your pictures, and once it's done, you can see the completion of the job. Again, it has a beginning and an end. We're going to look into that in a little bit. We have secret. Secret is the ability to store something in Kubernetes itself. But the cool part is not just that. The really cool part about a secret is that you can mount it as a file system into your container. And that's really neat. So you can take just opaque data out of maybe some encrypted data you have, you put it in the secret, and then you mount it into your container, into some location. Deployment config is the ability to tell Kubernetes in OpenShift when to deploy. For example, deploy when the config change happens, deploy when there's a replicate change, and so on. And then list is the ability to put all these objects together into one file. For example, if you wanted to put a service, a route, deployment config, and so on into a single file for the entire application, you could do that using a list. And lastly is a template, which is, let's say you wanted to create many Ruby on Rails apps. Some of them are for some customers, some of them are for others. What you do is create a template. The template is like a list, but it has variables in it that can be substituted. And we're going to be using that a lot as we go forward. So, any questions on OpenShift? All right, let's go to GlusterFS. Now, we're switching. So some of you may know OpenShift, but know Gluster. So now we have to go through a little overview of what GlusterFS is. GlusterFS is a distributed file system. Okay, it allows the file system, distributed file system, using a namespace that's across all accesses, and those accesses can be NFS, GlusterFS Fuse Mount, Samba, Object Store, or API access. So all those different methods of accessing see the same namespace. It's very important. Let's take a look at what a GlusterFS volume looks like. GlusterFS volumes can be set up in different types. We have distributed, meaning that you can take many nodes and put them together as one large volume. We've got distributed replicated as an example here, where you take those many nodes And then you make sure not only that they're distributed, but they're also replicated in the back end. We also support in GlusterFS EC if you want. And we also support different types of replicas. We got replica 2, replica 3, and a new one coming out, which is, what's the name of it? Replica 2 and Arbiter. Thank you. So let's take a look at an example of a GlusterFS, how you create a GlusterFS volume. You take a bunch of nodes, set up their directories according, so you have to first, create the file system on there using XFS on each one of the nodes. And then you define what order they're going to be. So in this one, it's a replica 2, so that means that the first one, my volume 1, and its replica is going to be in server 2 of my volume 2. You have to pick this. You have to set up the order. Once you set this up in one command, you can just start the volume and start using it. It's that simple. Right? Very simple to use. Now you have a unified replica 2 volume. But, this is great, and it was great when we were doing large volumes as a NAS system. But now we're looking at cloud. It's a little bit different. So we're going to do this, but we're going to do it for all of these systems. Right? Now you could be a little bit scared. Oh my goodness. I got to do what? Right? And that is where Hekeri comes in. Okay? Hekeri is a GlusterFS manager service that allows it takes care of the control of the life cycle of GlusterFS volumes. So it is a REST service. You communicate with it, and you say, I want a 100 gig volume. And it takes care of it for you. It takes care of the file system. It takes care of the location of the bricks, which is very important. And it takes care of making sure that the replicas are in their correct failure domains. The architecture of Hekeri is very simple. It has a REST interface. It has a database that we're going to be going into, talking a little bit more about, and where it saves all this information from all the clusters and all the systems that are out there that are being used for GlusterFS. So let's take a look at an example of how Hekeri works. Right? Let's say, for example, you want to set up 2 clusters. Maybe one is SATA and the other one is SPs. The first thing you need to tell Hekeri doesn't know anything right now at this point, but now you're saying, here's a node, Hekeri, and I want you to put this node on zone 1. So now if you're a GlusterFS person and you're saying, what is zone 1? Hekeri allows and enables GlusterFS to have failure domains. If you used OpenStack Swift or if you use Ceph, you understand what failure domains are. They are, for example, if 2 nodes are sharing the same power supply or the same switch, they're on the same failure domain. So if you enable, you tell the topology to Hekeri, you say this node is on this failure domain, or these other nodes are on a different failure domain. Okay? This information is needed by Hekeri to be able to correctly place your bricks across the cluster. So now it just knows the nodes. Second is that we're going to tell it all the devices that it's going to use. These are raw devices. They could be RAID or they could be just JBOD. And then we're going to do the same thing again for a new cluster. All right. So now that Hekeri has this information, then we're going to say create a volume. And we're going to say just create a replica 2 20 gig volume. That's it. That's all we're going to say. We're not going to tell it what bricks to use. We're not going to say anything about location. Just going to say create a 20 gig volume replica 2. The very first thing Hekeri is going to do is pick out the first brick and its replica. If you see here, it's picked up the first brick on the first node on zone 1, and its replica is on the second node on zone 2. Second is the second brick for distributed volume, and replica 2 is on the second zone. And that's how Hekeri works. Okay? So we put all these things together now. We got the technology of OpenShift. Okay? We got the technology of GlusterFS. And we got the technology of Hekeri. As we put them together now, it's much easier to see if we see it at demo. Okay? So let's take a look at that. The demo is set up as follows. We have a atomic system, atomic cluster using OpenShift origin 1.2, and then we have the client set up for it. You can't install RPMs on atomic, so we have a client that we're going to install RPMs into, and the client is going to be CentOS 7.2. In the nodes, as you see in the bottom, we have 3 drives on each of the nodes. So this could be blades or single 1U nodes, for example, that you have for OpenShift, and you have 3 drives available on each. Okay. So let's take a look at the demo. Any questions before I go into the demo?
I do have one. It was my understanding that GlusterFS would store things on each brick onto a file system.
Yes.
Not on a raw device.
That's correct.
Oh, so it takes the raw device and formats it.
Heketi takes care of creating the logical volumes, and then installs XFS on them, and then sets it all up for you.
Okay.
Any other questions? All right, let's take a look at the demo. All right, so the very first thing, this is on the client. The very first thing we're going to do is we're going to show the nodes. And here you can see all the nodes that are available. And I just want to pause it there because I don't think, it was so fast you probably didn't even see it. Right? Did anybody notice what just happened here? We just deployed GlusterFS in 3 nodes in 3 seconds. That's how fast it was. Okay? Sometimes things go so fast you don't see them, right? So the next thing we're going to do is deploy Heketi. There's a bootstrapping workflow right now that we need to do with Heketi, where we want its database to be stored in a very reliable location. To do that, we want to create a GlusterFS volume. To create the GlusterFS volume, we need Heketi. So the very first thing we're going to do is deploy a bootstrap Heketi, which is going to be able to do this for us. So as we go forward, the very first thing we're going to do is check out what we have in Heketi. We have nothing. As you can see here, we have no clusters defined. This is brand new. Doesn't know anything. Second thing is that we have a GlusterFS topology file. The topology file defines your topology. Remember in the slides I was showing you before, you tell it the node, and you tell it the devices. This is done for simplicity of the CLI. The CLI is just a REST client. If you had your own service, on management service for your nodes and such, you can just talk REST over to Heketi and insert that information into it. You don't have to use the CLI. But we're going to use the CLI for simplicity. And for simplicity, instead of typing each command for every node and every device, we created a single JSON file that defines the entire topology for us. So what we're going to do here is that we're going to insert this topology into Heketi by loading the data that's on this JSON file. So the very first thing we're going to do is you can see the nodes were above there. It creates a cluster. It goes to 100, 101, and then 102, and it initializes those devices. What does it do into the devices? It creates the PVs first and the VGs right on top of them. Okay? And now when we say cluster list, we have a single cluster, as you can see there. Okay? Any questions up to now? Right? So now that Heketi has all this information, the bootstrapper, it needs to set up the correct volume for the Heketi service that we're going to deploy after this. We're going to do that using OpenShift services. The very first thing we're going to do here is that we're going to call a command called setup OpenShift Heketi storage. What it does, it creates a volume, but then that volume needs to be managed by Kubernetes. So it creates this JSON file, which is actually a list of objects. And we're going to submit this JSON file into Kubernetes, OpenShift. Inside the JSON file, we have the following things. We have a secret, an endpoint, service, and job. Why? The secret, what the Hikari CLI client did was it took the database and did a backup of it. That backup was then inserted into a secret. Then the job at the end, what it's going to do, it's going to mount the secret and mount the volume and do a copy of the database for you. Lastly, the service and the endpoints are used to be able to mount the volume by containers in. So once we insert it, we get the jobs, we see that the job was successful. That meant that the container was started, the container is mounted to the systems, the container copied the database, and it's now ready for us. So the bootstrapping is complete. We can now delete the entire bootstrap system, and we can then deploy the real Hikari. So we got a GlusterFS volume with our database in it. Now we have Hikari, and this Hikari here. Again, these here are calling these processes, they're calling templates. Templates, again, are lists of multiple objects that have variables in it, and these variables are being substituted right there. So this Hikari system now is coming up and is expecting that volume to be created, which is all set, and it has the database right there. So what we're going to do now is that we're going to just set up an environment variable so we don't have to keep typing it again for the Hikari location. Okay? So now we say cluster list, and we see the list that we had before of clusters. All right? Now comes the fun part. Now the system is ready to be used. All right? Should I just pause it here and just stop for effect? So this part here, what it does is that it creates a 100 gig volume, and we're asking Hikari CLI to then take the volume and create for us a PV, just for simplicity. It makes it all one command. Takes a PV with the endpoints, and then we pass it right into the OC command. So it goes ahead, creates the volume, sets everything up, creates a JSON file, passes it on standard out of standard out, grabbed, and passed right into OC, and then it is registered right with OpenShift in all one shot. And again, when we have dynamic provisioning, this is not going to be needed. OpenShift will itself be able to communicate with the Hikari servers to create the GlusterFS volumes for you. But for now, this is the way you have to do it. So then, once the volume is then registered, it's available there. Now, we're doing a little thing here. This is just for the demo. You don't have to do this. We're just going to insert a file inside that volume for fun. So the very first thing we're going to do is find out the volume name, which is right there on the path. And then we're going to mount that volume right here on our client. Okay? So what it's going to do there is going to mount the volume, and then it's going to then access it in a few seconds. It's mounted. There it is mounted. We got 100 gigs. That was created by Hikari. We're going to go and create we're going to go to mount right there. We're going to see CLS. There's nothing there. It's brand new volume. And then we're going to type our little demo. So we're going to type it into index.html. Okay? So then what we do is we unmount it, and is now we save that file inside that system. All right, so now we're back, and this is the key right here. Check this out. You're an app developer. Normally when you want to set up your own app, you have to deploy, in this example here, we're going to deploy Nginx. You have to set up a system, you have to set up your DNS entry, you have to set up a volume. It takes time. Look at this here. This is really neat. This is a single file that defines your entire application. The very first thing on the top is defines a service, so we can expose that service as outside the cluster during the route. Second, actually third here, is the persistent volume claim. We're asking for a 100 gig volume. We're going to give it a name called Nginx claim. Lastly here is our Nginx, where we're going to then take our volume claim that we did there, We're going to then mount it into user share nginx HTML in that location. Can anybody guess what's going to happen? I just want to suspense again. So what we're going to do is we're going to go ahead and register that, which has all those objects inside of it. Then we're going to see that the claim got bound to our volume that we created recently. And lastly, we're going to run the command for that route, and we're going to get the data back. Only one shot. So, any questions on the demo? All right. Let's go back. And again, for more information, you can go to Hekeri. We are updating documentation as we speak. We're going to have demos there. We're going to have the ability to use Vagrant to set up your own systems, use Ansible with it. It'll make it much simpler for you to try it out. And we're going to have also RPMs upstream in CentOS and in Fedora. Right now they're on Copper, if you know what Copper is in Fedora. So, any questions?
How does the container mount the GlusterFS? Is using Fuse?
Yes.
Connected to the public API, public ID
Of the node. Yes. Actually, I kind of skipped over that. When in a topology file, it defines two networks. One is your management network, and the second is the storage network. Sometimes in some systems, you can deploy storage on OpenShift. You want to have your 1 gig for management and 10 gig for the storage network. And you can have it use a 10 gig network for all that I/O. Okay.
The implication is that the machine, the nodes that will run cluster is in the physical.
It could be physical, it could be a VM.
Yeah.
It's fine.
I'm thinking about production environment. So where I get advantage of this kind of user, because if it is a VM, in fact, I will use the same storage of Asana.
The same what?
The storage that came from Asana.
Oh, I see. Yeah, it all depends where the storage comes from. What you're doing is providing a storage management system to the administrator. So that's the difference there.
So if a node fails and Gluster is going to do a repair on the node, but you have a deployment or replica controller also running that detects the nodes down,
Yes.
do you have a race condition between two different frameworks trying to make up for the fact that a node has failed?
So,
Gluster and say Kubernetes.
so the way it works is it's as if Kubernetes wasn't there. So in a normal system, when a node comes up, the process comes up, right? GlusterFS or so, and it takes care of that node. So what Kubernetes is only doing, and when we showed the demo, is that we deploy GlusterFS only on a single node. That deployment of that container can only go into that node. It cannot be automatically moved to another one. So only when that node comes up, only then can that GlusterFS then repair. So there's no race condition. It's not like Kubernetes is trying to fix something. Kubernetes is only making sure that that one container comes up only when that node comes up. Because we put in the template that that container can only be run in that node. Cannot be moved to another.
Using a node selector.
Using node selector.
So to repair that condition, you'd have to get another node provision and put that node selector label on it.
Yes.
And it could take care of it.
Exactly right. Any other questions?
Question in case of rebalancing, if we have a fault of one cluster nodes, what's happening to the cluster? And if we have impact in terms of OpenShift cluster of the other core and the other application.
Okay. What's the impact of I'm trying to hear this way in the back.
Impact of rebalancing.
The impact of rebalancing, as long, again, if you have different NICs, then it's lowered. You still have to take CPU time. It's just like any other time with GlusterFS. then you can do a rebalance if you're familiar with it. As long, again, sometimes we are running same apps on other containers on the same system, and that's a different issue. But as long as, sometimes if you could have some impact on the application. I don't know how much CPU time, CPU performance it needs to do a rebalance. That's something we can discuss. But if with enough CPUs, you should be fine. And definitely the key is on the rebalance is the I/O. So as long as you have a storage network, then it should be fine.
So, what is, just to understand better, the containers that runs cluster are privileged containers?
Yes, they're privileged containers.
Have access to specific disk of a specific machine.
That's correct.
So that means that that code is not scalable.
Cannot be moved.
Okay, cannot be moved.
That cannot be moved. Exactly right.
So, to add to the answer about rebalance impact, within GlusterFS itself, in the next major release, we're going to be adding some controls over the impact that rebalance can have on the rest of the system to balance that activity with incoming user I/O. So when that feature becomes available with GlusterFS, the next step would be to integrate that with things that OpenShift is doing in terms of multi-tenancy and isolation and some of the features.
Any other questions?
If you really like GlusterFS and Teddy looks really attractive for the dynamic configuration, but you're not really sold on OpenShift yet,
Okay.
can you use just two out of your
Yes.
design?
Yes, you can.
So Teddy was just on it.
That's correct. You can try it out that way. Actually, it was a tech preview in RSGS 312. So yes, absolutely. Any other questions? All right, thank you very much.